comments. Hi my dear friends, this is Rajshekhar from Saimedha Coaching Center, Hyderabad. Good evening to all. Good evening to all. Right? Today I am going to discuss a small topic, a small concept in induction machines, which is very important for all the competitive examinations including GATE. They are asking questions in many competitive examinations up to now, which is very important. Let's see here. Are you ready everyone? Are you ready everyone? Comments. If you are ready, put in comments. Let's go for a small concept in induction machine. Right? 4999. A small concept in induction machine, that is especially speed control. Speed control of induction machine. Okay. Now we are going to discuss in this. Actually, speed control methods, we have many types. Many speed control methods. In that we are going to discuss one or two, just which are very important for all the competitive examinations. Let's see, generally in speed control methods we have a speed control methods from stator side and speed control methods from rotor side. Like that we have a two types of speed control methods. In that, from the stator side, supply voltage control by controlling the supply voltage. Next, by controlling the frequency, supply frequency. Of course, by controlling the voltage with V by F not constant, and by controlling the voltage with the V by F ratio constant, by controlling the frequency with V by F not constant, by controlling the frequency with V by F ratio constant. Like that we have a four types of speed control methods. Okay. Other than that, we have a rotor resistance control method. By including the rotor resistance or by connecting the extra resistance in series to the rotor, we can control the speed. Of course, by cascading method, we can control the speed. Of course, by injecting EMF into the rotor, we can control the speed. Yes, of course, by pole changing method, by changing the poles, we can control the speed. Like that, we have a many speed control methods for our induction machine. In that, generally the rotor resistance control method is important for like a AEE, assistant engineers, AEs in Genco Transco, like that, SSC, JEE, like a competitive examinations, resistance control. By controlling the resistance, we can control the speed. Based on that, they may ask you problem or they may ask you theory question also. That is very important actually. In that, you have to remember one thing, in that the slip always directly proportional to rotor resistance. Just remember this is the thing. Then you can get the answer whatever the question. Right? What is that? The slip is directly proportional to rotor resistance. If a rotor resistance increases, then slip increases. If the slip increases, we can reduce the speed. This is the concept in rotor resistance control. So by increasing the rotor resistance or by adding extra resistance in the rotor, we can control the speed. Based on that, they will ask you questions that is very important for like a competitive examinations. But generally for gate, the very important question is that voltage changing method or frequency changing method. These are very important for gate and ESC examination. Regularly they are asking questions. Even in that, they will ask you question on if the V by F ratio constant. Based on that, they are asking the questions in like a competitive examinations. Okay, for example, whatever the method, rotor resistance method or pole changing method, whatever, we have to assume that the full load torque should be constant. What is the assumption here? Here the mustard should be during the speed control, the full load torque of our motor should be constant. We have to maintain this one. Okay, let's go first concept. Now I am going to explain here voltage changing method. By changing the voltage, how we can control the speed as well as how we can control the torque even. Okay, so let's go for what that's a voltage control method. Right, let's go for that. Let's see. Here what I said that the speed control by voltage changing method, where full load torque constant, this is must and should, full load torque constant, and I said you in speed control method by changing the voltage we can control the speed. Here we have two types of speed control methods. One is that V by F ratio constant, other one is that V by F ratio not constant. We have two types of questions here. Is that V by F ratio constant or that V by F ratio not constant? We have to first see that. Okay, let's see here. Here full load torque formula. What is the full load torque formula? First we have to derive this. The torque T is equals to K V square S R2 by R2 square plus S square X2 square. This is actually the formula of the torque. After a long derivation, we can get this formula. Now I want full load torque formula. If you want full load torque formula, you have to take here full load slip. You have to take here full load slip. Of course, if you take here full load slip, the R2 square value is very greater than S square X2 square value, because at full load the slip is minimum just 5% to 12% in between. Very minimum, that's why this value is negligibly small. So the approximated full load torque formula is that K V square S into R2 by R2 square. K V square S into R2 by R2 square. Square R2 gets cancelled. So finally the full load torque formula, approximated full load torque formula, K V square S by R2. This is what the approximated full load torque formula. Not accurate formula, approximation formula. We are using only this one for to draw the characteristics actually. Right, sir. So let's go for that. What is here? What is K? K is equals to the constant 3 by omega. What is K, sir, here? K is equals to 3 by omega, nothing but 3 by 2 pi ns, 120 F by P, 120 F by P, of course, NS or NS by 60, whatever it may be. If it is NS by 60, here 60 is there. So like that. Okay, 3 by omega 2 pi ns by 60. So like this. So here K nothing but one frequency in denominator. K is nothing but one frequency in denominator. You have to observe this point. You have to observe this point where when V by F ratio constant, this point is critical point. We have to observe that one clearly. Right, just come here. Generally, what I said you, I am changing my voltage. I am changing my voltage, but there is no changes in rotor resistance. Rotor resistance is constant. Rotor resistance is constant. Now I am changing voltage. What I changing voltage? When voltage changes, the slip also changes. What is K here? I said you K is nothing but a frequency in denominator. So tell me what happened? The full load torque is directly proportional to V square by F into S. V square by F into S. V square K is nothing but 1 by F into S. But here the thing is that we are not changing the frequency. We are changing only voltage. Voltage changing method this is. We are not changing the frequency. Just we are changing the voltage, right? So even frequency also constant. No need to worry about frequency because here there is no any conditions. The V by F ratio may not be constant. You can change voltage as your wish. No problem at all. So we can change the frequency. We can change only the voltage. There is no worry about frequency. That's why to get a constant of full load torque, this value should be constant. To get a constant of full load torque, these two values combinedly should be equals to constant. Okay, so V square S should be constant, nothing but the slip is inversely proportional to V square. This is the formula. This is the formula. Based on this formula, they will ask you problem. Based on this formula, they will ask you problem. What I said here, this is the full load torque formula. Actually, the full load torque should be constant. But here rotor resistance already constant. We are not changing the rotor resistance. Of course, frequency also constant. We are not changing the frequency. That's why K already constant here. But we are changing the voltage, respectively slip also changes. If the combination is constant, then the total full load torque also constant. So to get the full load torque constant, V square S should be constant. Nothing but the slip is inversely proportional to V square. This is what the speed control method of voltage changing method with V by F ratio not constant. So how we can control the speed here? Just simple, by reducing the voltage. If voltage reduces, what happened? Slip increases. If I am going to reduce the voltage of supply, if the supply voltage decreases, then slip increases. When slip increases, speed automatically decreases. Like this, we can control the speed. We can control the speed. For example, now you have one doubt, sir. If voltage increases, what happens, sir? Very simple, sir. If voltage increases, slip decreases. If slip decreases, then speed increases. So 100 volts induction motor given by 800 volts. There is no analysis. Simply the insulation damages, winding burns out. Yes or no, guys? So don't increase the voltage without V by F ratio constant. If V by F constant, we can increase the voltage. But if you increase the voltage without V by F constant, it leads to damage of the motor. That's why this is only used for below rated speed control. Of course, this is used for slip ring and squirrel cage, both the induction machines, no problem with that. But this is only used for below rated applications, below rated speed control methods. Right, sir. Let's come to here. Voltage changing method with V by F ratio constant. If the V by F ratio constant, then what happens? Let's see, it's very simple. Let's see here, with V by F ratio constant, the full load torque should be constant. What is the formula for full load torque? Full load torque is equals to kV square S by R2. Here we are changing only voltage. Of course, we have to maintain frequency also constant. For example, I increased my voltage. To get a constant of V by F, we have to increase frequency also. Otherwise, V by F not constant. If you decreased the voltage, if you reduce the voltage, then to get a constant of V by F, we have to reduce the frequency also with the same fraction. Yes or no, guys? For example, 400 volts, 50 hertz. My V by F ratio 8. I reduced my voltage to 200 volts. I reduced my voltage to 200 volts. Then what is the frequency to get V by F constant? To get V by F constant, nothing but the V by F ratio should be 8. Then what is the frequency here? The frequency should be 25. If the frequency is 25, then V by F ratio constant. Nothing but if voltage reduced to half, then the frequency must and should be reduced to half. Then only V by F ratio constant. So, as usually, if voltage decreases, frequency also decreases. If voltage increases, frequency must and should be increased. Then only V by F constant. Then only V by F constant. Right, sir. So, here I just, the rotor resistance is constant. We know that. But here, the full load torque directly proportional to the K nothing but 1 by frequency and V square nothing but V into S. Now tell me, what is the relation to get a constant of full load torque? What is the relation here? To get a constant of full load torque, I said you already, the V by F ratio constant. There is no change of V by F ratio. 8, what we saw up to now. So this is already constant. So to get a constant full load torque, this combination should be constant. Nothing but the V into S should be constant. This is the condition to get a full load torque constant when V by F ratio constant. Nothing but the slip is inversely proportional to voltage. Once observe here, what is the difference between V by F constant and V by F not constant? When the V by F ratio is not constant, the slip is inversely proportional to V square. When the V by F ratio is constant, then the slip is inversely proportional to V. Now here, if voltage decreases, then slip increases, then we can reduce the speed. Now here, if voltage increases, then slip decreases, then we can increase the speed. Here, voltage increment also possible, voltage decrement also possible, because we are maintaining constant flux density or constant V by F. What is that? Constant V by F. Okay, guys. Okay, guys. Right? Okay, Jilan. Okay. Ramana, right? Are you listening? Right, sir. So next what is here? When the slip is inversely proportional to voltage, if voltage reduces, the speed reduces. If voltage increases, the speed also increases. The speed also increases. Right? Like that, we have to do some problems on this. This is very important concept. Based on this, they are asking the questions. First, in the question, you have to observe that is the V by F ratio constant or not constant. You have to observe this one. Then after, you have to go for formula. The slip is inversely proportional to V square. The slip is inversely proportional to V. Then after, try to do the answers. Right? If you know the slip, you can find the rotor speed. NR is equals to NS into 1 minus S. That's it. NR is equals to NS into 1 minus S. That's it. Okay, so let's go for one question here. Let's go for one question. For example, they will ask you a question like this: a three-phase 50 Hz 6-pole slip ring induction motor at 400 volts 50 hertz at 400 volts 50 hertz rotating at 900 rpm, rotating at 900 rpm. For example, voltage reduced to 240 volts, then the rotor speed is equals to how much? Like that they will ask you questions. Okay, so first you have to observe the question once again. A three-phase 50 Hz 6-pole. So for 6-pole machine, what is the synchronous speed? Synchronous speed is equals to 120 F by P. It gives us 1000 RPM. You know this very well. This is clear. Next, at 400 volts 50 Hz, my rotor speed is 900 RPM. Nothing but what is the slip here? Here the slip is equals to 1900. Then 100 is the slip. 100 nothing but 10%. 10% nothing but 0.1 or 10%, whatever it may be. 10% or 0.1. This is the slip normally. Now, if voltage reduced to 240 volts, there is no changes in frequency. And even it doesn't mention that V by F ratio constant. Otherwise, they may mention that frequency constant or V by F ratio not constant. Like that, they will give you. If he doesn't mention this, you have to take V by F ratio not constant. If he mentioned particularly V by F ratio constant, then only you have to take V by F ratio constant. Otherwise, they will give you here, they mention that voltage changes. What about frequency? Frequency not changes. Just he changed the voltage from 400 to 240 volts. Don't worry about frequency. So now tell me, what is the formula? Here V by F not constant, the voltage changing method, right? Voltage changing method, V by F not constant. That's why the slip is inversely proportional to V square. The slip is inversely proportional to V square. Then tell me, S2 upon S1 is equals to V1 square by V2 square. S2 is equals to S1 into S2 is equal to S1 into V1. Nothing but 400 upon 240 whole square. Nothing but S2 is equals to 0.1 into, what is that? 0 0 gets cancelled. 4 tens are 4 6 are 5 twos are 2 5s are 2 3s are. So simply 25 by 9, whatever it may be, 5 square by 3 square, right? So what is the answer finally? 25 by 90. 25 by 90 is my slip. So what is the rotor speed now? The rotor speed NR2 is equals to NS into 1 minus S2. What is that? NS. What is NS? NS is the 1000, because there is no change in frequency. Frequency is the same. If the frequency is the same, there is no change in synchronous speed. So tell me, what is the answer here? NS into 1 minus S. S is the 25 out of 90. 25 out of 90. Then what is the answer? 1000 into 90 minus 25. Yeah, exactly. 90 minus 25. 55 out of 90. 0 0 gets cancelled. So what is the answer, sir? 5500 by 9. You have to calculate it and give the answer. What is the answer finally? The rotor speed is equals to 9. 9 ones are 9. Tell me. 9. For example, 9 5s are 45. 9 6s are So 54 nothing but 10, 9 ones are 10 nothing but again 10, 9 ones are. So what is the answer? 611 RPM. Like that you have to calculate whatever the answer. So like that we have to do. Okay, so simply this is a problem for our induction machine speed control. Based on this, they may ask you question. Here you have to observe that V by F ratio not constant. V by F ratio not constant. You have to observe that thing. Right? Right? Okay. Then let's go for V by F ratio constant problem. That is very important for gate examination. Okay, right. Before that, before going to that question, once you see here in our examination, few more questions are asking, very important. What is that? One is the starting torque to the maximum torque formula. Based on this, full load torque to the maximum torque formula. These are two generally very important. So tell me, do you remember these formulas? If you take a starting torque formula kV square R2 by R2 square plus X2 square. What is the full load torque formula? Sorry, starting torque formula. You know already full load torque formula. Full load torque formula kV square S R2 by R2 square plus S square X2 square. Full load torque formula. And the maximum torque formula kV square by 2x2. Like that, take these ratios, then full load torque to maximum torque ratio is 2 into slip at full load into slip at maximum torque by slip at full load square plus slip at maximum torque square. This is the formula for full load torque to the maximum torque. And starting torque to the maximum torque formula same, 2 into slip at full load, right? Slip at starting. What is the slip at starting? Slip at starting is 1 into slip at maximum torque SMT by what is the slip at full load and slip at starting? Nothing but 1 square plus SMT square. As usual, both the formulas are same. Just the starting slip is equals to 1. That is the change. Okay. So like this, they will ask you questions on this, just these formulas. Sir, starting torque to maximum torque is there. Full load torque to maximum torque is there. What about starting torque to full load torque? Starting torque to full load torque is equals to starting torque to full load torque is equals to S full load into IST by I full load whole square. This is what the formula for starting torque to the full load torque. This formula we used at starters generally. This is used for starters to calculate. So these three formulas are very important for any competitive examination. We can expect one question from these three formulas. Okay, you have to remember these three formulas. Actually, we have to derive starting torque, we have to derive full load torque, we have to derive maximum torque, and we have to take torque T is equals to 3 I square R2 by S omega. Based on this, we have to calculate it. But I am not doing all those things, just a simple concept here we are discussing. Directly formulas, the starting torque to full load torque, starting torque to maximum torque, full load torque to maximum torque. Based on this, they will ask you questions in our competitive examination. These are called simply the torque formulas. I forgot one formula here. Of course, you know very well. The slip at maximum torque is equals to. Can you tell me what is the formula? The slip at maximum torque is equals to. Can you tell me? Is R2 by X2. The slip at maximum torque is equals to R2 by X2. For example, they will ask you a question. to get a starting torque is equals to maximum torque. What is the condition? I want that at the starting only I want the maximum torque. Then what is the condition? Can you tell me? At starting only, to get the maximum torque, R2 by X2 should be equals to 1, or simply the rotor resistance is equals to rotor reactance. Then we can get at the starting only we can get the maximum torque. This is what generally the formulas which are very important for our examinations, competitive examinations, other than GATE, like a Genco Transco, Assistant Executive Engineers, and like a HNWS, and like a SSC JE, whatever the examination, we can expect 100% question from this. 100% question from this. Right? Very good, very good. Okay, so let's go for some problems based on this one problem and based on our V by F ratio constant one problem, previously asked problems. Okay, let's go for those problems once. Okay, are you ready now? Let's go for problems. Let's go for problems. See here. See this problem. This is already previously asked problem, which is very important. Very good, Ramana. Very good, RR. Right, sir. So once go through the problem first, then after give me the answer. Once go through the problem. See here. See here. The speed of a 4-pole induction motor. What is that? This is a 4-pole induction motor. Is controlled by varying the supply voltage. See here. By varying the supply voltage, while maintaining the ratio of supply voltage to frequency constant. The supply voltage to frequency constant, they mentioned clearly in our question. They mentioned clearly the supply voltage to frequency ratio constant. Okay, at rated frequency of 50 hertz and rated voltage of 400 volts. What that? Rated voltage of 400 volts and rated frequency of 50 hertz. Its speed is 1440 rpm. Its speed is 1440 rpm. Then find the speed at 240 volts. The same question previously what I done in the whiteboard, but here V by F ratio constant, but in previous problem V by F ratio not constant. That is the change. So here the find the speed at 240 volts if the load torque is constant. This is the assumption I said you already. I told you already. Always full load torque should be constant. Okay, so let's see, for a 4-pole machine, what is the synchronous speed? For 4-pole, what is the rated frequency? 50 Hz. For 4-pole, 50 Hz, the synchronous speed is 1500 rpm, you know already. Yes, at starting my synchronous speed is 1500 rpm. At starting my voltage is 400 volts. What is V by F ratio at starting? My voltage is 400 volts and my frequency is 50 hertz. Nothing but my V by F ratio 8. My V by F ratio 8. Now we have to maintain V by F constant again. But the given V2 is equals to 240 volts. Then what is the F2? Can you tell me what is the F2? At what value of F2 we can get V by F ratio of same? Can you tell me? Give me the answer. At what value of F2 we can get the same value of V by F constant? Yes, at the value of 30 hertz. F2 is equals to 30 hertz. Then we can get the V by F ratio constant. V by F ratio constant 24 by 3. 3 ones, 3 eights. So now the second frequency is 30 hertz. Second voltage is 240 volts because they clearly mentioned that we have to maintain V by F ratio constant. Now tell me, sir, if V by F ratio constant, what is the formula? S inversely proportional to V. S inversely proportional to V. So S2 by S1 is equals to V1 by V2. S2 by S1 is equal to V1 by V2. So S2 is equals to S1 into V1 by V2. What is V1? V1 is the 400 volts and V2 is the 240 volts. Of course, these two gets cancelled. 4 tens are 4 six are 4 tens are 4 six are. And what is S1? S1, the synchronous speed is 1500, but my rotor speed is 1440. Ns minus Nr, Ns minus Nr by Ns. So let's calculate it. 0, 0 gets cancelled. 6 ones, 6 tens, and 0, 0 gets cancelled. So what is the slip at this condition? My slip is 1 by 15. 1 by 15 is the slip at this condition. Okay. So let's calculate it. Let's calculate it. NR2 is equals to, can you tell me? Generally 90% of people doing wrong in this step. Here NR2 is equals to NS2 into 1 minus S2. But in previous problem, we taken just NS. But here we have to take NS2 because here frequency changes to 30 hertz. If the frequency changes, automatically, what happens, sir? Automatically, synchronous speed also changes. Now tell me, for 4-pole 30 hertz, for 4-pole 30 hertz, what is the value? 4 ones, 4 threes, so 30 30s, 900 is the RPM. So NR2 is equals to 900 into 1 minus S2. What is S2? 1 out of 15. 1 out of 15. So calculate it. 1 minus 1 out of 15. So what is the answer? 900 into 14 out of 15. 14 out of 15. 15 ones, so 15 60s. 16 14s. 16 10s, 600. 4 6 240. So finally the answer is 840 RPM. 840 RPM. What is the answer, sir? Here the answer is 840 RPM is the correct answer. So actually this is the procedure to deal this problem, but it will take a time, right? Sir, is there any trick to solve this within seconds, within less than 1 minute? Do you have any trick to solve this? Can you tell me? Do you have any trick here? Come on, sir. Yes, we have a trick to solve this. We have a trick to solve this. Let's see what is the trick here. Let's see what is the trick here. How we can delete this? Right. Let's see what is the trick here. Very simple. The change in speed or the slip speeds are constant. If the V by F ratio constant, then the slip speeds are constant. This is the formula. That's it. Slip speeds nothing but Ns minus Nr is equals to Ns minus Nr. That is constant. What is NS1? NS1 is the 1500. NR1 is the 1440. What is NS2? We have to calculate NS2. So just we calculated V by F ratio constant. Nothing but 400 by 50 is equals to 240 by F. What is the F we just calculated? I got F is equal to 30 hertz, right? F is equals to 30 hertz, right? If the F is equals to 30 hertz, NS2 is equal to 900. Of course, we know, we just saw it. Now tell me what is the answer? Here 900 minus NR2 is equals to 1500. 1500 minus 1440. The slip speeds are constant. So 900 minus how much it is to get a 1500 minus 1440, nothing but 60 RPM. What is the value here? If this is the 840 RPM, that is equals to 60. 900 minus 840 is equals to 60. So 840 is our answer. Very simple question actually. Within seconds you can get the answer. Don't go for totally problem. Just you have to use this trick. So slip speeds are constant when the V by F ratio constant. Even this is the voltage control method or frequency control method, whatever it may be. If the V by F ratio constant, then the slip speeds are constant. You have to remember this one. Okay, guys? Okay, right? Let's go for next question. Let's go for next question. So this is the second question. Once go through this. A different question actually. See here. A 3-phase 50 Hz 6-pole slip ring induction motor rotating at 900 RPM. What is that? 6-pole 50 Hz. 6-pole 50 Hz, nothing but the synchronous speed is 1000. We know that. And the rotor speed is 900 RPM, nothing but the slip at full load is 10%. The slip at full load is 10%. Next, 900 RPM at full load torque of 100 Newton meters. They given the full load torque also. The full load torque of 100 Newton meters. And it's a standstill. Rotor resistance and reactances are 5 ohms and 20 ohms, R2 and X2. If they given R2 and X2, the slip at maximum torque is equal to R2 by X2. R2 by X2 nothing but 1 by 4. 1 by 4, nothing but 25%. 1 by 4 or 25%. This is the 25% and this is the 10%. Okay, next, respectively, then find starting torque of motor. Oh, now see here what they asked. Starting torque of motor. How we can calculate this? They given the full load torque. They given full load slip. Of course, we calculated. They given SMT. Then how we can get full load torque? How we can get starting torque? We have two formulas, of course. One is the starting torque to the maximum torque. Other one is the full load torque to the maximum torque. These two formulas. But here they given the full load torque. Now they are asking the starting torque. They given the full load torque. Now they are asking the starting torque. But there is no relation combinedly for these two. Of course, we have a starting torque to the full load torque. But what is that? S into current at starting to the current at full load whole square. There is no current values in my question. This formula is not applicable for this question. So we have to make any new formula here. So from this is the 2 into SMT by 1 plus SMT square. 1 plus SMT square. And this is the 2 into S into SMT by S square plus SMT square. S square plus SMT square. We have to calculate our required formula, starting torque to the full load torque. We have to calculate this now. So 2 into SMT cancelled. Then what is the answer here? S square plus SMT square by S square plus SMT square by. So tell me, we have to calculate this. We have to calculate this. The maximum torque cancel. These two gets cancelled. These two gets cancelled. Then tell me what is the answer here? S square plus SMT square. This goes numerator. Next, Now in the denominator, s into 1 plus SMT square. This is what we have to calculate first. Then after, of course, you can get the answer. So tell me what is the answer here? The starting torque is equals to full load torque into nothing but 100 into S square plus SMT square. S square nothing but 10%, 10 by 100 whole square plus SMT square nothing but 25%, 25 by 100 whole square upon S nothing but 10% again, 10%, 1 plus SMT square nothing but 25 by 100 whole square. You have to solve this. If you solve this, you can get the starting torque value. Like that, we have to do here. Like that, we have to do here. So simply, of course, you can calculate this. This gets cancelled. Of course, this is the 100 here. So let's see here. Let's see here. Let's calculate here. What is that? 10 square by 100 square. T is equals to 100 into this is 10 square nothing but 100, 25 nothing but 625. 100 plus 625. 100 plus 625. 725 by, of course, this is 10,000 and this is 10,000 gets cancelled out because 100 square common for LCM 10,000. Here also 100 square 10,000 gets cancelled out. So 10,000 plus 10,000 plus 625. 10,625. Of course, here 10 is there. Of course, here 10 is there. This 0 also came here. Now 10,625. So you have to calculate this, then you will get a answer of what is the starting torque. Like that. Here the thing is that you have to first calculate starting torque to the full load torque formula from this. Then you can get the answer simply, just a substitution and a solution. By substituting and just by simplifying the formula, what is the calculations, you will get the answer. Like that, these are the questions which are time consuming, but we can get easily. Okay, these type of questions are very important, like a GATE and other competitive examinations. Okay, prepare well. Who are preparing for GATE, just go through all our videos, just download our Saimedha GATE mobile app. You can find many videos, like many problems, all previous GATE problem solutions. You can find many videos also. You can get a good rank in your GATE by the support of our Saimedha. So prepare well. All the best to everyone. And tomorrow, in tomorrow class, we will meet with next very interesting and very important topic from any other machine. Right? Thank you. For more details, go for our Saimedha GATE mobile app. Okay? Thank you very much.